Hello friends, in this video tutorial we are going to learn about the basic combinatorics and permutations. So to look into, let's first of all develop some of the basic tools. What is a factorial notation? Many of the answers which come out in this particular combinatorics are expressed as factorial. So let's look into what is a factorial. Simply this thing is read as n factorial, which is equal to multiplying all the natural numbers till we get n, that is 1 into 2 into 3 into n minus 1. Let's look at an example. That is, if you want to calculate 3 factorial, it will be equal to 1 into 2 into 3, which will yield us 6. Okay. To get a firm grasp, just calculate the factorial of natural numbers till 8. That is, calculate 0 factorial, 1 factorial, 2 factorial, 3 factorial, and so on till 8 factorial. To verify the answers, just refer to the book. It's very easy. Okay. So now we look into what is a permutation. So before going to that, just we'll first of all look into what is the fundamental principle of counting. So it states that if an event can occur in m different ways, the following which another event can occur in n different ways, then the total number of occurrence of that event together in the given order is m into n. To get a feel of this, just take an example. Let's say we have a key lock which has which has only two digits, and the two digits can be from 0 to 9, and here also they can be 0 to 9. Then as you can see, we can form different combinations of the lock, and these combinations, for this combination, the first digit can be any from 0 to 9, that is, it can be 10, and similarly second digit can also be any of the 9, that is, the numbers can be from 0 to 99, which are 100, which can be obtained by simply saying the combination for individual numbers, which is 10 into 10, hence the answer, that is 100. To verify this, let's take a simpler example. Say if we toss two coins, the possibility of events which could turn out, let's write it down. So the first die when tossed can result in a head or a tail. Okay. So, and the second dice corresponding to the first die can also have a head and a tail. So we'll have these four combinations. That is head head, head tail, tail head, and tail tail. So if you simply work out, it can be simply seen that this is equal to the combinations for the outcome of the first die into the combination of the outcome of the second die, that is 2 into 2, which is equal to 4, which is the total number of outcomes of the two die when we toss two dice. Similarly, if we have more than two plays to fill, or say two different events occurring together in a particular sequence, then we have the similar result. That is, say if the third event, if together with these event occurring at m and n times, they let the third event occur in p different ways. Okay, so then the total number of ways will be m into n into p. Okay, and similarly you can work out for if we have events more than 3 and so on, it will be simply m into n into p into q into r into s into, where m and p q are respective ways of occurring the events. Okay, so to get a grasp let's look into an example. uh, in example you have to make different combinations from the four letter words from the word rose. So let's not do it with the fundamental principle first. Let's try to work out a simply by writing different combinations which could occur. So this includes some tedious tasks, but I would like you to do it by yourself first, because uh, you'll get a feel of what is happening, actually happening. So let's write down some of the basic uh, ones. That is, first one can be rose, then it can be ROSE. We write down all the mm, letters first. That is R, S, and ROSE, and then we write down the combinations, which can be ROSE, ROES. Then we have RSOE, RSEO, REOS, RESO, and similarly, if you work out, we have ORSE, ORES, we have OSRE, OSER, OERS, OESR. Now, if we replace O with S, we get SORE, SOER, SEOR, SERO, SROE, SREO. How many are these? These are six here, and six here. And now if we place as the first one, we get EOSR, EORS, ERSO, EROS, ESRO, and ESOR. Just work these out. These are simple, but will will help you to develop the basic sense of what is the fundamental principle of counting. As you can see, we have uh, 6 plus 6 plus 6 plus 6, that is 24 different combinations, which can be easily seen that if we see that selecting a word consists of four events, that is choosing the four individual letters of the word. So first letter of the word can be chosen in four different ways. That is, it can be ROSE. The next one can be chosen in, no, most of you might have got wrong. It will be 3, because if let us assume that we choose R as the first letter, then will be left with only 3 letters for the next choice. So we will have only 3 choices for the next one, which is let's say we choose O. Then similarly, using the same logic, we'll be left with only 2 letters for the next one. So we could have only 2 choices, that is ROSE. Then we could have only will be left with only single choice, that is E for the last one. So we'll have choices as 4 into 3 into 2 into 1 individually, which can be written as 4 factorial. So here we have developed two basic senses. First of all, we looked into this question from the sense of the fundamental principle of counting.